Okay, so today we'll solve GET 2022 20 question from real analysis. This is a question number 31. So a function from R to R is given by this. This is a summation from n to 0 to infinity 1 by 2 to the power n, characteristics of interval n to 1 n plus 1. And define for alpha belongs to R. Let's define this function S alpha is all such x such that fx is bigger than alpha, strictly bigger than. Then 4 options are given. You have to check which one is correct. Okay, so you have to check basically this set is open, closed or measurable. These are the 3 things you have to check for different values of alpha. Okay, so this is the NPTEL reference. This you can check. Okay, let's try to solve this one. So let's try to understand what this function is. So fx is given summation n equals to 0 to infinity 1 by 2 to the power n, characteristics of n to n plus 1. What is this means? Means characteristic function of means whenever x belongs to in this interval, this gives the 1. So basically characteristic of suppose any set x is it's 1 if x belongs to a and 0 if x does not belongs to a. So this is the definition of characteristic function. Now look how this function will look like. So let's say this is 0, this is 1, 2, 3, 4 and etc. So if suppose note that what happen when x equals to 0. So if x equals to 0 and if you put n equals to 0, so note so n equals to, so this interval is basically note that this n equals to 0. So if you put n equals to 0, you will get open 0 to 1, this interval, and for n equals to 1 it will get 1 to 2, so it will shifting right. So at x equals to 0, this is open, so at x equals to 0 it's not there. Characteristic function will be takes the value 0 because x is 0 is not in the interval for n equals to 0 to infinity. So at the point x equals to 0, function will take the value 0, right? So here 0, and for any x negative this is the same because this is from n equals to 0 to infinity, so intervals are shifting right. So this is the 0 function from minus infinity to 0. And what happen when if for n equals to 0, it will give the interval 1 and close to, open 1 close to, and there it will be value, it will give 1, right? So at this point it will take 1, but it is open. And from if you put n equals to 1, so it will give the interval 1 to 2 and it will take the value half. Right, next it will take 1 by 4 like this. And so on, right? Like this function. And So how this function will, this you can write. So fx, if you write it explicitly, so it will take the value 0 whenever x in minus infinity to 0, right? And 1 when x is in open 0 to closed 1. Next it will take half when x belongs to open 1 closed 2, and like that, right? And dot dot dot. So it will take 1 by 2 to the power n if x belongs to in this interval n comma n plus 1. So this is the function fx. Okay, now let's check what we have to find. And s alpha is given, you have to find s half is open or not first. And what is s alpha? For alpha belongs to some real number, you define s alpha all such x in R such that fx is strictly bigger than alpha, right? So first a we are doing, so s half we have to check. What is s half? So all such x in R such that fx is bigger than half. Okay, so you have to find all the points where f is bigger than half, strictly bigger than half. So note that which points is bigger than half. So these are the only take when it is take the value 1, it's bigger than half, right? So it is in the interval open 0 closed 1. So this point open 0 closed 1. So this set will be, so all the points where it is bigger than half, it's open 0 closed 1. So is this set open? So this is not open, right? Because 1 is not an interior point. So S sub is not open. Right. So option A is false. Option B, you have to find S root 5 by 2 is not measurable. Same. S root 5 by 2. So this is all such x is again R such that fx is bigger than root 5 by 2. Not that root 5 by 2 it's bigger than, so root 4 by 2 it's 1. So it's strictly bigger than 1. So all such x where f is take the value is strictly bigger than 1. But there is no such point where f will take the value bigger than 1, right? So the set will be empty because all the values is less than 1. So this set will be empty, right? The function will not take the value, any points in which function take the value bigger than 1. So this set is empty. And we know empty set is measurable. So S root 5 by 2 is measurable. So it is saying that option saying that it is not measurable. So this is again false. Means this is not true. So we get this is measurable. And option C is saying that S0 is closed. Let's find what is S0. So S0 is all such x such that fx is bigger than 0. So you have to find all such x whose function is bigger than 0. Now note, for minus infinity to open 0, function will take the value 0. So this will not come. And for close 0, and for open 0 to infinity, function will always take the value bigger than 0, right? Because it is of the form 1 by 2 to the power n. So from close open 0 to infinity, all such points will be there. So this set will be open 0 infinity. So S0 is closed. and not closed. Because this is open interval. And option D, what it is saying? S 1 by root 2 is measurable. S 1 by root 2. So this is all such x such that fx is bigger than 1 by root 2. So which points will come? So bigger than 1 by root 2. Note that 1 is bigger than 1 by root 2. So all such points where if we'll take the value, this is inside this set. And is this true? That but half is not bigger than root 2, right? So this because root 2 is less than 2, right? So these points, so only points where function will take the value 1 are only inside this set, right? So this you can take also. So this set is same as, because 1 by root 2 is somewhere here. So only point where it will take the value 1 will be there. Same as fx equals to 1. So this set will be open 0, closed 1. So this is again measurable. Right. So this set is measurable. So what we have got? So yes, 1 by root 2 is measurable. So the which option is correct? Yes, 1 by 2 is open. So this is not correct. S half is not open. So this is false. S root 5 by 2 is saying not measurable, but we have got S root 5 by 2 is measurable. So option B is false. S0 is closed, saying, but we have got S0 is not closed. It's open interval. So this is again false. And S 1 by root 2 is measurable, that we have got. So option number D is correct. Okay.